30. What is the secret of bird migration? When I was young, I used to see flocks of wild geese flying in the blue sky in my homeland in late summer and early autumn. Just as described in the primary school textbook, autumn is coming and it is getting cooler. A flock of wild geese is flying southward, sometimes in the formation of the fork and sometimes in a line. One day, at the turn of the rainy and dry season this year, I was queuing at a service station in Zimbabwe, where petrol was in short supply. Suddenly, some noises in the sky caught my attention. I looked out of the car window and spotted a dozen crow-like birds perched on a large tree not very far away. They were flapping their wings and making caw-caw-caw noises. Out of curiosity and boredom, I began to watch them, figuring that they must be holding a meeting and discussing the implementation of a certain project. Unexpectedly, however, their calls attracted more and more birds of the same species from all directions. In less than half an hour, nearly 1,000 birds had gathered. Suddenly, they flew away from the big tree and hovered and rose higher and higher in the sky. I wondered whether they were holding a party in this manner of hovering or were they selecting Miss International with the most elegant flight. I came out of the car and stood on the lawn beside the road, watching them. They were hovering higher and higher in the sky until they looked smaller and smaller. I wondered, are they competing to fly the highest? Unexpectedly, the birds that flew the highest suddenly flew northwest along a straight line. The others were still circling, but they also flew along the same straight line when they reached the same height, as if they had boarded a train and rode away along the fixed railway. I finally came to realize after hard thought that those must be migratory birds. At the beginning, they clambered on the tree to hail the flock to fly together to a distant place. Later, they flew by hovering in order to increase altitude. When they reached a certain height, they met an air current. It helped them to fly to distant places more easily. Oh, how clever the migratory birds are! After returning home, I checked some documents about migratory birds and discovered more surprising facts. For example, Arctic terns build nests in the Arctic Circle. They fly to the South Pole at the turn of summer and autumn. They fly back to the North Pole next year. Every year they travel for 35,200 kilometers. There is an oriole called blackpoll warbler, small in size and weighing only 20-odd grams. Before autumn comes, they fly from Alaska, America, to the east coast of Canada or New England, where they feast on all the dainty food to increase its fat and strength. Then, when it is turning cold, they begin a long journey of flight, first toward Africa, over the Atlantic Ocean, then after taking over an air current, they turn to Brazil in South America. The whole journey is 3,840 kilometers at an altitude of more than 6,000 meters. The flight lasts 4 days and 4 nights. The white storks in Europe fly 12,800 kilometers to spend the winter in South Africa. The long-tailed cuckoos in New Zealand fly 6,400 kilometers to spend the winter in the Pacific Islands. Seagulls in England's Isle of Man fly from Wales to Brazil at over 700 kilometers a day for 16 consecutive days. The wild geese fly over the Himalayas mountains at an altitude of 9,000 meters. What is more incredible is that generally, the older generations of cuckoos start their journey earlier. Smaller cuckoos usually start their migration a few days later. Unaccompanied by their parents, small cuckoos make their first flight to a strange place and can fly to their destination unerringly and unite with their parents. On the contrary, young starlings set off earlier than their parents and reach their destination all by themselves. Marvelous. Incredible. I wonder how they know that the cold weather is coming. How do they know which day is suitable for flight? How do they know that there is an air current at an altitude of thousands of meters? How do they know that this air current would carry them to their desired place? How do they know that that remote place is now a time of spring and flowers with sufficient food? What power has propelled them to embark upon such an epic journey across oceans? How do they travel round trip without going astray? How do they identify directions while flying? How do they find their habitat without being accompanied and guided by their parents? I searched for scientists' explanations and found the following 4 major answers. Something like a biological clock inside the migratory bird can sense the upcoming cold and the appropriate time to take off, and can calculate the position of the sun while flying in the sky and determine its direction and route of flying by continuously adjusting the angle between itself and the sun or stars with the help of the sun, the moon, and the stars. An inherent meteorologist, migratory birds can determine the duration of their stay at the habitat and the timing of migration according to meteorological conditions such as temperature, lighting, wind direction, and rainfall. They can choose a sunny day to begin their flight, adjust their flying manner according to the changes and fluctuations of wind directions and barometric pressures, and make use of the ascending air current for gliding to save their energy. Extremely sensitive to geomagnetic waves, migratory birds can identify their directions according to geomagnetic waves and can decide the time of migration and habitat according to the geomagnetic information known to them. Through millions of years of evolution, birds have gradually realized the rules governing the seasonal changes of climates and have formed a fixed pattern through generations of accumulation of experience and passed on the genetic information to each succeeding generation. All four explanations above seem reasonable, but a deeper analysis may reveal that they are fanciful and groundless. According to the first explanation, it seems that migratory birds can calculate their own positions, identify their direction, and derive the direction and route of flight based on the position of the sun. Well, isn't it the migratory birds who calculate the airflow at an altitude of several kilometers? Wow, migratory birds are much smarter than Einstein. With a brain the size of a little finger, they can calculate the airflow in the sky at an altitude of several kilometers without using instruments or measurements. Moreover, they can fly and calculate their direction without using a compass, a sextant, a compass, or a calculator. It's too miraculous and extraordinary. This explanation is too mythological and absurd. According to the second explanation, migratory birds are born meteorologists who can take off on a sunny day by choosing different climatic conditions. This suggests that migratory birds are more knowledgeable than all the scientists and engineers in meteorological bureaus worldwide. However, in abnormal weather conditions, migratory birds might miss the air current in the sky and have to wait for the cold current. This could be fatal for them. Swallows always return accurately to the nests they built the year before. It is said that swallows in a small town in America always return at dawn on March 29th of the following year. How should we interpret this phenomenon? The third explanation is a little mythical. Migratory birds can identify the direction through geomagnetic waves and decide the time of migration and habitat according to the geomagnetic information known to them. However, it is unclear how migratory birds can detect the existence of air currents at an altitude of thousands of meters using geomagnetic waves. The fourth explanation is a typical theory of evolution and seems flawless. As we know from the description of the chick's breaking of the eggshell in the preceding section, the theory of evolution is challenged by the fact that the first chick hatched from the first egg laid by the first hen on Earth could break the shell without inheriting any genetic information or shell-breaking skills. Therefore, is the theory tenable when it comes to migratory birds? Based on the radioactive isotope determination method, scientists believe that the Earth is 4.6 billion years old, animals appeared about 1.8 billion years ago, invertebrates about 438 million years ago, fish about 380 million years ago, amphibians about 290 million years ago, and reptiles about 245 million years ago. Dinosaurs died out about 135 million years ago, mammals appeared around 65 million years ago, and humans appeared about 1.6 million years ago. First, let's not question the accuracy of the radioactive isotope dating method. Assuming that this method is reliable, birds have existed on Earth for at least several hundred million years. If they are intelligent enough to pass on information to their offspring about how to navigate, select favorable habitats, fly from the North Pole to the South Pole, use air currents for flight, and locate the places where their ancestors lived, why haven't they evolved into more advanced animals over the course of millions of years? Instead, humans have taken over and made it impossible for them to escape our air guns and nets. Do birds not want to continue evolving, or have they hit a roadblock in their evolution? If we don't believe in the greatest creator, we can only think randomly. The question of whether the egg has appeared before the chick or the chick has appeared before the egg will remain a mystery for another 10,000 years. My explanation for the migration of birds is that everything in nature has its definite purposes and means of subsistence, and they each have features irreplaceable by other species. Otherwise, all will die out. What if tigers can both dominate the mountains and fly in the sky? What if mice can dig holes and also can build nests in trees? What if antelopes can live on grass and also eat the flesh of other animals? What if dogs can give birth to offspring and also can lay eggs? What if apple trees can bear apples and also bear watermelons? Wow! It's really amazing. The answer for migratory birds' migration is instinct, just like bees that build honeycombs with a rhombus bottom consisting of 109.28 degrees obtuse angles and 70.32 degrees acute angles. What is instinct?